What's up, reptiles? We are going to review trig identities and solving trig equations today. This was your final unit for my class, so it should be pretty fresh in your mind, right off the vine. Haven't even lost the peach fuzz off of it yet. So hopefully I don't have to really batter this one like I have the other ones, but if it needs a little bit of battering, make sure you hop in the WebEx, say, Mr. Barton, I need you to beat the life out of this problem for me. And I'll be happy to do that. Otherwise, let's do some review. So here is your list of trig identities. If you do not have all of these in one place, you're going to want to go ahead and put them all in one place right now. You could take a second and pause the video and write them all down. Hopefully you have a bunch of these memorized already, though. You have, of course, the tangent identity. The reciprocal of that is cotangent, so you just flip the identity. Your reciprocal identities, so just how you change between cosecant, secant, and cotangent back into their parent identities, sine, cosine, and tangent. The Pythagorean identities, the one that everybody, their mom and their dog knows, sine squared plus cosine squared equals 1. If you take this starting identity and either divide everything by sine squared, you will get this one down here. Or if you divide everything by cosine squared, you'll get this middle one. Then you have your cofunction formulas. These are just related to the graphing that we did yesterday. Yesterday we saw that if we have a sine graph like this, and we have our cosine graph, something like that, I don't know, that you can turn them into each other by just sliding them over. So that's what these cofunction identities are. They just say that if you take a sine graph or a cosine graph and slide it far enough, it turns into the other one. They're pretty obvious that you need to use them because of this thing. Anytime you see a pi over 2 minus theta, that's like a big red flag saying or maybe a green flag saying, hey, switch me. And then we have our even odd identities. These just have to do with the symmetry of our unit circle, where if we look at sine here or sine here, they're going to be the same height, but this one will be positive, this will be negative. So if you go negative that angle, you get negative the y value. For cosine, it's just saying that if you go this angle or this angle, the x value is the same for both of them. So cosine of the negative angle equals cosine of the positive angle, because we're talking about the x on the unit circle. And then the tangent, cotangent, cosecant, and secant can just be kind of inferred from these two. So not too bad. All right, there are your identities. Hopefully you have them all in one nice, convenient place so that you don't have to go flipping through your notes when you want to use them. I recommend memorizing them. However, some of you are cowards and won't do that. But, you know. All right, so we're going to talk about simplification, verification, solving, and then the two laws, the law of sines and the law of cosines. But before that, let me just reiterate some handy tips for you. We're not going to use all of these tips in this video because I don't think you want to sit through another 50-minute video. But if you do want to see all of these tips in action, you could go look at the 12.1 video where I got them from. So if you are trying to simplify something like this, some tips for you are try and factor stuff. Usually if you see cosine of x plus sine of x, cosine of x equals something, then you can factor that cosine out, right? Factoring is useful. Sometimes it is useful to substitute the reciprocal trig functions. So if you see a secant somewhere, it might be helpful to turn that into a 1 over cosine, because this cosine might cancel with another cosine somewhere. Or you might be able to turn it into like a sine over a cosine and then turn it into a tangent. This one is probably one of the most important ones. Look for squared trig functions and a 1, whether it's positive or negative. This is a big hint to use one of the Pythagoreans. Either the sine squared plus cosine squared equals 1, or one of the ones with tangent and secant, or cotangent and cosecant. Last thing you might want to try is trying it. Just try stuff, and if it doesn't work out, you can try again. So don't give up. Be patient. These things are difficult. Yeah, that's all the advice I have for you. Good luck. All right, let's look at our example. So we are just trying to simplify this. One of the problems with simplifying is that no one's really going to tell you when you're done. So our goal here is kind of two, maybe even threefold. We want to get rid of fractions if possible. We want to condense to one term. Yeah, twofold. We'll call it twofold. That's our goal. We want to make it not a fraction, and we want to get it down to as few terms as possible. So let's look at this thing. There are no squared trig functions yet, but we can kind of see, based on all the conjugates we've messed around with in this class, that if I multiply these two bottom terms out, because they're conjugates, they'll probably simplify pretty nicely. So let's go ahead and start with that, shall we? So we've got negative. We'll leave the 1 on top alone. If we FOIL this out, 1 times 1 is 1. 1 times negative sine is negative sine. Sine times 1 is positive sine. And then sine times negative sine is negative sine squared. Then we can see the two signs in the middle cancel each other out. And we have 1 over 1 minus sine squared. And we have that negative in front. All right. Now this is one of those trig functions that I've warned you about several times. A squared trig function and a 1. So which of the three Pythagorean identities has sine squared in it? The one that everybody knows. It's sine squared plus cosine squared equals 1. So we have a 1 and a sine squared here. So let's move the sine over to be with the 1 by subtracting sine squared. These cancel. So we get cosine squared x equals 1 minus sine squared x. And you're going to notice that I don't typically put the argument here. It's because usually it doesn't change throughout the problem. But again, this is my own laziness. Be better than me, students. You want to be the change you want to see in the world. Do as I say, not as I do. You should probably put them there, but sometimes you don't need to. So 1 minus sine squared equals cosine squared. So let's go ahead and replace this with our cosine squared. So we have negative 1 over cosine squared. Well, 1 over cosine equals secant. So if I square this side, I can square this side. So 1 over cosine squared is equal to secant squared x. And let's not forget our negative from in front. And then this is as simple as we could make that. We could probably turn it into a tangent if we really felt like it, but I feel like that's going to make this more complicated. This is a single trig function that's being squared with a negative sign in front of it. That's not too bad. That's pretty good. There's no fractions, and it's in one term. That's pretty simple. All right. Now, let's look at this. This problem says verify the identity all that means is that they want you to show the steps to either turn this into this or this into this. My advice is start with the difficult stuff. How do you spell that? Difficult. Sound it out. And try and simplify it. Because starting with the simple stuff, sometimes it's hard to complexify it or difficultify it. Because you just have so many different options you could take this thing that it becomes a little confusing. Usually taking it from over here to that step, back down to that step is a little easier. So let's look at the complex side or the difficult side. I shouldn't say complex. That has a special meaning in math. First thing I notice is that I have a trig function and a 1. So let's go investigate that. It's probably a Pythagorean identity. So secant squared theta minus 1. This is related to the tangent one. So it's tangent squared theta plus 1 equals secant squared theta. And if you don't believe me, you can always go back to this and see that I'm telling you the truth right there. So we have the secant and the 1, so we're going to move the 1 over by subtracting 1 on both sides. And then we can see that tangent squared theta equals secant squared theta minus 1. So this thing that we have, these two terms can be replaced with this single term tangent squared. So let's do that. So we have tangent squared theta over secant squared theta equals sine squared theta. Now we want to think to ourselves, we're trying to get to a sine. Where are there some sines hidden in this? Well, tangent is equal to sine over cosine. So let's go ahead and expand our tangent out and see if that helps us. So we have sine squared theta over cosine squared theta. This is our tangent, all over secant squared. Okay, so that equals sine squared theta still. We are not quite there yet. That's an ugly 2. All right, that didn't really help. That looks more complex. So here's our sine squared. We need to get rid of this cosine. Where could we get another? Oh, secant is 1 over cosine. So secant squared would be 1 over cosine squared. So let's make that substitution as well. And let's cross our fingers that it'll cancel out. So we're going to have sine squared over cosine squared all over 1 over cosine squared. So we have a fraction divided by a fraction. So we can instead flip the bottom fraction and multiply. So we're going to have sine squared over cosine squared times cosine squared over 1. We multiply straight across, and we can see that the cosines will cancel out. And we get sine squared equals the thing we've wanted the whole time, true love. Just kidding, sine squared. All right. And that's our verified identity. Look, we did it. We proved that this big ugly thing is equal to this little nice looking thing. Not so bad. All right. So let's talk about what the difference between identities and just plain old solving are. Identities are always true. What that means is that theta equals just all real numbers. It doesn't matter what number you plug in for theta, this thing will always equal this thing. When we are solving, that's not true. When we're solving, we want to know x equals something. It's not going to be all real numbers. That's not equal. You can't do that. What that might mean is like sine of x equals 1/2. the angle that I plug into sine, it matters for me to get 1/2. If I do sine of 90 degrees, that equals 1. So obviously, x can't be 90. X has to be 30 degrees. That one will give us 1/2. So when we are solving, this is not always true. It's only true for specific x's. So it's our job to find those specific x's. So my advice for solving for x is very similar to solving polynomials. You want to move everything to one side, factor as much as possible, and get this thing equal to 0, because usually it's pretty easy to find stuff equal to 0. So let's start by moving our 2 cotangent x over by subtracting. So we'll subtract 2 cotangent of x to 2 cotangent of x. This side cancels and equals 0. This side, these are not like terms. This is like xy minus 2x. You can't combine them because you have no idea how big y is. So what we're going to do is we're going to leave these separate. So we're going to have cotangent of x cosine squared of x minus 2 cotangent of x. Now we can see that there is a, oh, come on. I love this program. It's so good. Okay, what color are we on? Blue, good. We can factor out a cotangent of x because it's in both terms. So let's do that. So we'll take our cotangent of x to the outside, and then we'll have left over this cosine squared of x minus 2 equals 0. So now if we can get this thing to equal 0, 0 times anything is 0. Cool. If we can get cosine squared of x minus 2 to equal 0, then perfect. 0 times anything is 0. So what we're going to do is now take our two factors, or the two terms, and individually set them equal to 0. So cotangent of x equals 0, and cosine squared x minus 2 equals 0. All right, let's start with this cotangent. So cotangent is 1 over tangent, or cosine over sine. Cosine is the x value of the unit circle ordered pairs. Come on. I love it when stuff works. So cosine tells us the x's for this ordered pair, and sine tells us the y. So what we want to know is when is x equal to 0, because that will tell us when, because 0 divided by anything is 0. So we want to know when is the x 0. So that happens right here and right here. So x from this cotangent equals this angle, which is 90 degrees. The answers on your homework will probably be in radians, so we would put pi over 2. And the other place it happens is right here. So x could equal 270 degrees, or 3 pi over 2. Usually the problem will say find all the solutions from 0 to 2 pi, like this. Actually, usually I think it's like this, where, whoops, that's a parenthesis, where if the answer is 2 pi, they want you to just say 0 instead, because they're the same thing. But these would be our two answers. All right, let's look at this cosine. So we're going to have cosine squared x. We're going to add the 2 over, so equals 2. We're going to take a square root. So cosine of x equals plus or minus radical 2, which is plus or minus about 1.41. Now we need to know some information about cosine. Cosine is the x. Here we're at 1, 0. Here we're at negative 1, 0. So the range of cosine is from negative 1 to 1. Those are kind of the upper and lower bounds of cosine. We cannot get to 1.41. It's outside of the range of this function. So what that means is this equation can never be true. So we get no additional solutions from this part of our equation. So our only solutions on the interval from 0 to 2 pi are those two right there. All right, pretty fun. I really enjoy these. I hope you do too. Probably not, but you know, not everyone is lucky enough to enjoy math. All right, last topic we need to talk about are the law of sines and the law of cosines. Let's go ahead and label them real quick. This is the law of sines, and both of these are the law of cosines. Fun trivia fact about law of sines: if it's easier for you or it works out better for your problem, you can take this entire thing and flip it upside down. So you can do sine of A over A equals sine of B over B equals sine of C over C. If you want, you can put the signs on top. It doesn't really matter. For the law of cosines, this bottom one is just this top one, but we've solved for the cosine of C. That's just to make it easier for you so you don't have to do all the algebra to get this thing by itself. I don't have this memorized, disclaimer. I have the top one memorized, but if you're going to college, you probably don't need to memorize the bottom one. I'm just putting it here so that if you're one of those poor, wretched souls who doesn't plan to continue your math studies once you go to college, this is just here as a crutch for you, like a walker for an old lady or old man. Feel free to use it if you need it. So there we go. Law of sines, law of cosines. Let's do some examples. All right. Law of sines. Let's talk about how do I know I should use law of sines here. So let's go ahead and label this thing. Let's call this angle A. We'll call this angle B. And then we'll call this angle C. The sides are the same letter but lowercase directly across from the angle. So directly across from angle A is side A. Directly across from side B, or angle B, is side B. And directly across from angle C is side C. So here's A, B, C, B, A, and C. Maybe capitalize that a little more. All right. So let's say we want to find side B. If we start setting up our law of sines, let's look at A first. We have side A. That's good. We have 27.4. And we have angle A. So we have sine of 28.7 degrees. Equals, we don't know side B. We want to get side B, but we do know angle B. So we can do sine of 102.3 degrees. If you can set up your law of sines so that you know one entire fraction, top and bottom, then it is possible to use the law of sines. If you cannot fill out the A, B, or C part of the fraction entirely, top and bottom, law of sines is not going to get you there, and you are forced to use the law of cosines, which is a little bit more work because, I mean, look at this equation. This is much uglier than this. So luckily, if we want B, it's pretty easy to find because we have the law of sines. So let's go ahead and find side B. All we have to do is multiply both sides. Oops, that's not what I wanted. All right, we'll put it back. By this denominator to get B by itself. So times sine of 102.3 degrees. Multiply the same thing on this side. So these cancel, and side B equals sine of 102.3 degrees times 27.4 divided by the sine of 28.7 degrees. So we're going to go ahead and put that in a calculator. And of course, I've done this ahead of time. Just let me grab my notes really quickly. Ignore the tapping of keys that you may hear. That's me leafing through my notes. Again, always be prepared. Always prepare your notes ahead of time. I'm sorry, I just have so many really in-depth, really fantastic work here. It's hard for me to decipher all the greatness from one set, you know. So I found it here. B is 55.7471, and you can round to wherever you want, whatever's asked for. If we wanted C from here, we could easily find angle C, because triangles tell us that A, let's use the correct notation, angle A plus angle B plus angle C equal 180 degrees. So we could do some arithmetic to solve for C. We just subtract A and B, right? Minus A minus B on both sides. So we get C equals 180 minus A minus B. Plug in some numbers and do some arithmetic. Use your calculator, you'll live. Then, because we have C at this point, you can set up your fraction with C over sine of C and get your last side. We're not going to do that because I don't think you want to sit through an hour of lecture. All right, for the law of cosines, let's go ahead and label these. We'll call this C and C. How about A and A, B and B? If I try and set up my law of sines just to demonstrate, we would have 60 over sine of A. We would have 46 over sine of B. And then we would have x over sine of 45. None of these are completed fractions. We're missing A, we're missing B, we're missing C. So because none of these fractions are finished, it's impossible to use the law of sines to solve this. You have to use your law of cosines. So let's go ahead and solve for this missing one using our law of cosines, which is C squared equals A squared plus B squared, Pythagorean theorem, minus 2AB cosine C. The important part when you're setting this up is the side you're looking for should match the angle you're plugging in, and then everything else is the other two sides. So let's go ahead and plug in our variables and our numbers. We have x squared equals 60 squared plus 46 squared minus 2 times 60 times 46 cosine of 45. All right. Now you throw this big meat beast into your calculator, which I, of course, have done beforehand. I would never dare dream of not putting this in a calculator beforehand because I'm a responsible, forethoughtful adult. And I'm going to keep telling myself that. All right. So we plug this whole thing into our calculator. We get x squared equals about 1,812.77. My calculator is cutting off at 2 decimals for some unknown reason. Or not my calculator, my notes, of course. But you want as many as possible. The more rounding you do, the worse your answer is. But I'm not your mom, so I can't make you round a whole bunch. Except I write the answers, so I kind of can. And then we take a square root of both sides. When we take a square root, normally you would get a plus or minus here. However, sides can't be negative because you can't go negative 3 feet unless you're doing physics. So take a square root, just take the positive answer. It's about 42.4 0.58, rounding. This is in feet, so this would be in feet. And there we go. We have reviewed Unit 12, 30 minutes flat, new world record. If you have any questions, please hop in the WebEx. Let me know what they are so I can help you. Disclaimer, when you do law of cosines on your homework, you are probably going to have to do this process. I should use my pen. 2 times. Unfortunately, the homework problems are a little dastardly, and they don't just let you do the law of cosines like my handcrafted example here. This is to cut down on your viewing time and increase your practice time. You can thank me later. But not in the comments below because they're disabled. Make sure you like and subscribe, bell icon. See you guys later.